Hello everyone, this is EEL, and today I will talk about cooperative spectrum sensing optimization with energy detection in cognitive radio network. Nowadays, with the rapid development of wireless communication technology, such as the cellular mobile phones, satellite televisions, Wi-Fi, and Zigbee, Bluetooth, we are suffering from spectrum scarcity. And though we are suffering the spectrum scarcity, the spectrum utilization is pretty low, as can be seen from the figure. The spectrum utilization ranges from 15% to 85%, while in 3G band the utilization is only 30%. To solve the spectrum scarcity and increase spectrum utilization, cognitive radio is proposed. Cognitive radio is a radio which intelligently detects which communication channels are in use and which are not, and adjusts its operating parameters to use the vacant channels while avoiding occupied ones. The cognitive radio is a two-layer architecture. The first layer is the primary users. A primary user is a user who has license for specific band, so he can use the band as he wants. The second layer is the secondary users. A secondary user is a user who does not have license for the specific band, but he tries to access the band opportunistically when primary user is not using the band. The key technique lies in cognitive radio is the spectrum sensing. The objective of spectrum sensing is to decide whether a primary user is using its band. The sensing task is done by secondary user. The sensing task can be viewed as a binary hypothesis, as can be seen from the equation below. H0 is the fact that the primary user is not using his band, and H1 means the primary user is using his band. Xt is the signal the secondary user sensed, and omega t Wt is the white noise, and the St is the primary user signal. If the primary user is not using the band, the secondary user will only sense the white noise, and while the band is in use, the secondary user will sense the primary user's signal plus the noise signal. And after get the signal, he says xt, he will derive a detect parameter z, and by comparing z with a threshold lambda, if the z, he will decide whether the primary user is using the band or not. If z is larger than lambda, then he decided the primary user is using the band, and vice versa. Here we will introduce several parameters to evaluate the performance of sensing algorithm. The first one is the detection probability. It means the secondary user decided the primary user is using the band while the primary user is using the band. And false alarm probability. The secondary user decided the primary user is using the band while the primary user is not. And the false dismissal probability. The primary user decided the secondary user decided the primary user is not using the band while the primary user is. And the last one, empty probability. The secondary user decided the primary user is not using the band while the primary user is or is not. And the spectrum sensing can be divided into two main categories. First one is the single non-cooperative spectrum sensing, and another one is the cooperative spectrum sensing. And the single non-cooperative spectrum sensing means that the secondary user senses the channel condition and decide whether primary user presents independently. Here we will introduce one algorithm for spectrum sensing, that is the energy detection algorithm. This means the secondary user decides whether the primary user is in the channel according to the signal energy they sensed. And however, single non-cooperative spectrum sensing is vulnerable to hidden node and channel fading, since the secondary users won't change information with each other. To solve this problem, cooperative spectrum sensing is proposed. In cooperative spectrum sensing, secondary users will share their information sensed and make decisions based on the information they share. The cooperative spectrum sensing can be divided into two categories. One is the centralized one, and another one is the distributed one. The centralized spectrum sensing has in the centralized spectrum sensing there exists a master node. The master node, the task for the master node is to gather information and make decisions. And in the distributed spectrum sensing, there is no master node, and secondary users will share their information with each other and make decisions together. And the current research work mainly focuses on centralized spectrum sensing, and this is what we adopt in our work. The centralized cooperative spectrum sensing can be divided into two categories. One is hard combination, and another one is soft combination. In hard combination, the secondary users upload local decisions to master node. This means after they sense the signals, the secondary users will make a local decisions, and they will upload local decisions to the master node. And the master node will make decisions based on several principles, such as add principle, OR principle, and the K-reg principle. Add principle means that the master node will decide the primary user is present only when all secondary users decide the primary user is existing. And OR principle means that the master node will decide the primary user presents when at least one secondary user decides the primary user presents. And K-reg principle means that the decision the master node will decide the primary user presents when at least K secondary users decides the primary user presents. And in soft combination, the secondary users will upload their sensed information to the master node. Here, we need to decide a weight for each secondary user, and we will introduce two methods to decide the weights. One is maximum ratio combination, and this is based on the SNR of each secondary user and equal gain combination. This means the master node will give each secondary user equal weights. Okay. Then we do a simulation for energy detection based cooperative spectrum sensing. And we showed error rates varying with the threshold at different numbers of secondary users. Here we will do a program demonstration. For here we will insert how many secondary users we want to cooperative sense the spectrum. Assume we want 6, and run the program. It takes a second. So when we are waiting, let's talk about the advantage of soft combination. Okay. Since the hard combination only uploads the decision to the master node, so the soft combination uploads more information to the decision and to the master node. So the master node will know information and do some better decision. So the accuracy will be better than the hard combination. However, because you did some you did more communication with the okay. Oh, here we got the okay. So we can say the blue one is the theoretical ones, and the red one is the simulation of our results. Uh, it looks pretty good. Okay, let's go on talk about the okay. So because there is more information exchange between the master node and the secondary users, so the overhead will be large. We need more capacities to more channel capacity to communicate. So this is one disadvantage of soft combination. Also, cooperative cooperative spectrum sensing. Okay, that's it. Thank you.